Welcome back to our educational video series. In today's lesson, we will tackle about the nature of roots of a quadratic equation using its discriminant. So let's dive right in! Welcome back to our educational video series here in Mathematic. In today's lesson, we will be exploring the nature of roots of a quadratic equation using its discriminant. By the end of this video, you will have a clear understanding of how to determine whether the roots are real, imaginary, or equal. So let's dive right in! Today, our discussion will be about understanding the nature of roots of a quadratic equation through its discriminant. Firstly, we should know the definition and formula. The discriminant is calculated using the formula to triangle, which is called delta equals b squared minus 4ac, where the triangle or the delta represents the discriminant, b is the coefficient of x, and a and c are the consonant. Now that we know how to calculate the discriminant, let's discuss its significance in determining the nature of roots. The value of the discriminant can be classified into three cases. The first case: when the discriminant is greater than 0, it means that there are two distinct real roots for the quadratic equation. This occurs when the graph of the equation intersects the x-axis at two different points. Second case: when the discriminant is equal to 0, it means that there is only one real root for the quadratic equation. This occurs when the graph of the equation touches the x-axis at a single point, known as the vertex. Third case: when the discriminant is less than 0, it means that there are no real roots for the quadratic equation. In this case, the graph of the equation does not intersect or touch the x-axis at any point. Instead, it lies entirely above or below the x-axis. Now let's work through a couple of example problems to solidify your understanding. For example, let's consider the quadratic equation is 2x squared plus 5x plus 2 equals 0. To determine its nature of roots, we need to calculate the discriminant using the formula triangle, or which is the one representing the discriminant, equals b squared minus 4ac. In this case, b is equal to 5, a is equal to 2, and c is equal to 2. Plugging these values into the formula, we get the triangle or the delta or the discriminant equals 5 squared minus 4, 2 times 2 equals 25, minus 16 equals 9. Since the discriminant is greater than 0, we can conclude that this quadratic equation has two distinct real roots. Let's try another example. Consider the quadratic equation is x squared minus 6x plus 9 equals 0. Again, we calculate the discriminant using the triangle or the discriminant equals b squared minus 4ac. In this case, b is equal to negative 6, a is equal to 1, and c is equal to 9. Plugging these values into the formula, we get the triangle or the delta or the discriminant indeed equals negative 6 squared minus 4, 19 equals 36 minus 36 equals 0. Since the discriminant or the triangle is equal to 0, we can conclude that this quadratic equation has only one real root. And there you have it. By calculating the discriminant of a quadratic equation, we can determine whether its roots are real, imaginary, or equal. Remember, if the discriminant is greater than 0, it indicates two distinct real roots. And if the discriminant is equal to 0, it indicates one real root. And if the discriminant is less than 0, it indicates no real roots. And for another fun fact, and for another additional idea, a quadratic equation is an equation of degree 2 in the form ax² plus bx plus c equals 0, where a is not equal to 0. The value of x in this equation is called the roots of the quadratic equation. There are only two roots in a quadratic equation. The nature of these roots can be real and imaginary. Thank you for listening. I hope you learned something. Please like our channel. Bye-bye!
Hello,